Alright guys, so now we're going to move on to day 2. Alright, day 2 notes, we kind of got into our normal distribution. And so we're going to go over these notes. Alright, so normal distribution is basically your normal data set, which is a bell curve. I put normal in parentheses because that basically means like out of 100%. Okay, so under the curve, we are covering 100%. All right, so we have the empirical rule, which is 68, 95, 99.7. Those are the numbers that I told you were going to be like your best friend. You need to make sure that you know what those numbers mean. All right, so 68% of the data under this curve will be within 1 standard deviation of the mean. 95% of this data will fall between 2 standard deviations of the mean. And 99.7% of the data will fall between 3 standard deviations of the mean. We will also take it a little bit further as if it was out of 100%. Okay, so my mean is always going to be in the middle. All right, that is my mean. Standard deviation, you'll see like this word here, our symbol for that looks like a little sideways B a little bit. Okay, so these are the numbers that are important for you to know. 68% is from 1 standard deviation away. You see it's -1 and then +1. 95%, the arrows are going out to -2 standard deviations and +2 deviations. And then my third set of data, 99.7%, goes out to -3 standard deviations and +3. So if we break this down a little bit further, all right, my bell curve, the middle is my mean. That little mu means the mean, okay? So from 1 deviation, plus and minus from the mean, is 68%. From two standard deviations away from the mean is 95%. And 3 deviations away from the mean on each side is 99.7%. All right, so let's take a look at the breakdown, because these numbers are important, but it's also very important that you know the breakdown. So I'll put my calculator over here so you can see it. All right, so 68%, if that is divided up into 2 equal divisions, each piece will be 34%. So this is 34, and this is 34. All right, to find my next piece, I'm going to subtract 95 from 68, which leaves me with 27. Okay, I'm going to divide that 27 by 2, which gives me 13.5. So that means that this piece here is 13.5%, and this is 13.5%. All right, then I'm going to move on to the third tier. 99.7 minus 95% is 4.7. If I divide by 2, I get 2.35%. So this piece here is 2.35%, and this is 2.35%. And then there's 2 more boxes over here, because that's saying, let's say that we want to bring out our standard deviations to 100%. If we want to do that, 100 minus 99.7 divided by 2 gives me 0.15 for each piece. So this is 0.15 and this is 0.15. All right, and the more that we did this, the more that these numbers were just engraved in your brains, honestly. You just have to know what these percentages are. All right, so let's move on to the next page of notes. All right, example one. Example one says, I bought a set of movies. The average price was $15 with a standard deviation of $3. Label the normal curve with the mean and 3 standard deviations on both sides. All right, so let's see what they told us that's important. The average price was $15, standard deviation of $3, and we're going 3 standard deviations on both sides. So the average price is my mean. Your standard deviation was $3. So let's go ahead and fill this in. My mean always goes in the middle. So my mean is $15. For the sake of this, we're not going to put the cents, just whole numbers. Okay, so then I'm going 3 deviations from the mean on both sides. Now this graph is not completely drawn to scale, but that's okay. We know what it looks like. All right, so because we're going 3 deviations from the mean, this means this is -1 deviation, -2 deviations, and then -3. So on the other side, I have 1 deviation, 2 deviations, and then 3 deviations. Because my standard deviation is 3, if I'm going towards the negative side to the left, I'm going to subtract 3 each time. So this leaves me with 12, 9, and 6. On the other side, I'm going to the positive side, so I'm going to add 3. So I have 18, 21, and 24. All right. A says, let's turn all the prices above into their z-scores using the formula. In order to do that, we need to know what the z-score is. The z-score is going to be your standard score. All right, so this formula here is something that you need to know because we're going to use it a lot. You'll eventually memorize it. You also need to know what these variables mean. Z is your z-score, x is your original value, the mu is your mean, and this little tilde thing is your standard deviation. All right, so let's see here. We're going to use this data to answer these questions. My mean was $15. My standard deviation was 3. Okay. So find the z-scores for the following prices and star on the curve above. All right, so I'm finding the z-score. My formula for z-score is x minus the mean divided by standard deviation. So this data point is my x. That's what they're telling me to use. So x is going to be 17.85 minus the mean, which was 15, divided by standard deviation, which is 3. When you type this into your calculator, make sure that you type in the top of your fraction, press enter, and then divide by 3. We always round to 2 decimal places. So my z-score is 0.95. Okay, so for that data point, the z-score is 0.95. All right, the next one, my data point is $25. So 25 minus 15 divided by 3. I've already done the work, so I'm just going to type it in or write it in. This is 3.33. And for the last data point, my data point was 850 minus 15 divided by 3. and that gave me negative 2.16. All right, on the other side it says find the prices for the following z-scores given. All right, so now they gave us the z-score. So positive 2.5 is equal to, I don't know what my data point is. That's what it's saying. Find the prices. So x minus my mean, which is 15, divided by 3. If I were you, I like to turn these type of problems into a proportion and work them out that way by cross multiplying. So 1 times x minus 15 is equal to 3 times 2.5. So you would get x minus 15, which was equal to 7.5. You can add 15. So x equals 22.5. That was my data point. All right, just give me a second. I'm going to go ahead and write in the rest of them. And because we've already worked this out, I'm just putting the answers here to save some time. You can also type this into Desmos. And that will surely speed up things for you. Alright, so here we are. We've used the z-score formula to find the z-score and to find our data point. Alright, our last example here. Give me a second. Alright, so for example 2. Hold on 1 second, guys. All right, example 2 tells us to answer the question below. Several families bought snacks for the field trip. The average cost was $6.50. That's important. So my mean is $6.50 with the standard deviation of 0.75 cents. They just told us to label the curve. So in the middle, I'm going to put my mean, which was 6.5. And we assume that we always at least go 3 deviations out from the mean. If we ever go 4, that means we're going the full 100%. Okay, so my numbers here, I'm going to subtract 0.75 going to the left. So I'm going 1 deviation, 2 deviations, and 3 deviations. So this gives me 5.75, 5, and 4.25. Alright, going to the left, I have 1 standard deviation, 2 standard deviations, and 3 standard deviations. So that gives me, let me just calculate this, make sure I don't make any mistakes, 7.25, 8, and then 8.75. Alright, so what is the third standard deviation below the mean? The third deviation below the mean would be 4.25. What is the plus 1 standard deviation? Positive 1 standard deviation is 7.25. what is the difference between the third standard deviation and the minus second deviation? Well, your third deviation is 8.75 minus negative 2 deviations. So 8.75 minus 5 will give me 3.75. All right, D, what is the range of values that represents the middle? Plus 1, so that means plus positive 1 deviations and minus 1. So the range would be from 5.75 to 7.25. What does a fourth standard deviation from the mean represent? So if we were to go out to 4 places, which we're capable of doing, all right, that would just give us 9.5 and 3.5. So what would that represent? Well, one, it will represent 100% of data. The positive 4 would be 9.5, which essentially is $9.50 compared to what we're talking about. Okay, so that is the end of day 2.